Section 24.3 Constructing hybrid orbitals for non-equivalent ligands. Bent's rule states that in a molecule, smaller bond angles are formed between electronegative ligands. Since the central atom to which the ligands are attached to tends to direct bonding hybrid orbitals of greater p character towards its more electronegative substituents. For example, CH3Cl. The three CH bonds involve the sp 2.8 hybrid orbitals of carbon. The carbon-Cl bond is sp 3.5. Overall, the weighted average is sp3. 2.8 times 3 plus 3.5 divided by 4 is 3.0. So on average, it's sp3. But towards the hydrogen atoms, it's sp 2.8, slightly lower than 3. Towards chlorine, it's sp 3.5, slightly greater than sp3. In the sp 2.8 hybrid orbital, the percentage of the p character is 2.8 over 1 plus 2.8. So this is s to the power 1. 1 plus 2.8. The percentage is 73.7%. It's lower than 75% in sp3. Now in the sp 3.5 hybrid orbital, the percentage of the p character is 3.5 divided by 1 plus 3.5. So this is s, this is 3.5 is the p character. So it's 77.8%. And this number is greater than 75%. Now let's look at the bond angles. The hydrogen-carbon-hydrogen bond angle is 110.5 degrees, a bit higher than the 109.5. And this HCCl bond angle is 108.4 degrees, a bit lower than 109.5 degrees. So we can see the higher the percentage of the p character, the smaller the bond angle. And why is that? So first, we know the p orbitals have higher energy than the s orbitals in the many electron atoms, such as carbon. And two, the electronegative substituents or ligands attract electrons. Now because the p-type electrons have higher energy, they are more likely attracted to the electronegative ligands. So that's why. In this case, CH3Cl, the p electrons are more attracted towards this chlorine atom. Now let's relate the p character to the bond angles. We learned this. The angle between the sp hybrid orbitals is 180 degrees. In the sp hybrid orbitals, we have 50% p character. The angle between the sp2 hybrid orbitals is 120 degrees. In the sp2 hybrid orbitals, there is 67% p character. The angle between sp3 hybrid orbitals is 109.5 degrees. In sp3 hybrid orbitals, there is 75% p character. Now, what if we have 100% p character? The angle is 90 degrees. So you can imagine the angle between px and py, or between px and pz, or between py and pz is 90 degrees. So now you see the trend. From 50% to 67% to 75% to 100%, the bond angle decreases from 180 degrees to 120 to 109 to 90. So now we can tell the more S character is in the two bonds that constitute an angle, the greater the angle is. Whereas the more p character is in the two bonds, And then we have a smaller angle, closer to 90 degrees. And this explains why this CHC bond angle is slightly greater than 109.5. This HCCl is slightly less than 109.5. Now here's another question for you to think about. If we have this molecular structure, X can be hydrogen or chlorine. When X is hydrogen, the HCH angle is 118 degrees. When this X is chlorine, the angle is 111.4 degrees. Why is this?